Hi, my name is Sean Noyes. I'm a Redis Senior Cloud Solution Architect dedicated to Azure, and today I'd like to welcome you to our talk on solutions for scale with Redis Enterprise, including active geo-replication, extended data modules, plus new scaling features. Now, when we talk about Azure Cache for Redis offerings, it's helpful to understand that there are 5 tiers available for customers. There's basic, standard, and premium tiers, which are forks of the open source project. And there's Enterprise and Enterprise on Flash, which are a joint engineering effort between Microsoft and Redis. Now, that allows us to bring together these teams to create powerful features available for customers in Azure. These include active geo-replication, the Redis extended data types, which we'll talk about here in a few minutes, 5.9's availability, and we provide joint support with Microsoft, where Microsoft provides round-the-clock support and takes the first call and has a direct line to Redis experts for any escalation necessary. Now, the customer benefits from this in streamlined administration because they get integrated billing. They are able to use their Azure spend commitments, Azure security integration, Azure monitoring tools, and they configure their cluster through the Azure portal, Azure CLI, ARM, Bicep, or Terraform templates. Now, before we talk about the Azure extended data types, I'd like to point out some things about the Redis Enterprise architecture. So every Redis cluster is comprised of several different Redis Enterprise nodes. Now, at the core of these are Redis open source shards that you may be familiar with. These are single threaded processes which run within the enterprise node. And on top of that is a set of management software which helps to govern the cluster and orchestrate failure detection and failover, as well as stats collection. Now, part of the magic sauce of these Redis Enterprise nodes is the Redis Enterprise proxy. There's a proxy on each node, which helps to orchestrate the network connections and multiplex and multipipe the commands that are going into those Redis shards to avoid any back pressure on the system. Now, all of this comes together in this shared nothing symmetric architecture. So in a 2-node cluster, you would have a primary node and a secondary node. The primary node is receiving all of the requests for the workload and handling all the writes, while the secondary node is replicating itself against that primary node and is available at any time to be promoted to primary in the event that the health of the primary node becomes questionable. The primary node will then self-heal and then be promoted into the new secondary mode without any performance issues. Now, it's worthy to mention that there's always an odd number of nodes, and in the Azure portal, when you stand up a cluster, you'll see that you have 2 nodes or 4 nodes or 6 nodes, etc. But there's always an odd number of nodes which you won't see in the portal, and that odd number is really just used for quorum contention and doesn't store any data at all. So one of the features that we have for Redis Enterprise is Redis on Flash, whereby we extend the DRAM and the RAM available for your Redis Enterprise cluster with SSD. And this gives a really great cost benefit against performance, of course, for customers who need very large cache sizes. So right now, the Redis on Flash tiers can go up to 12 terabytes of cache. And they operate on what's considered hot and warm values. So in this architecture, all of the keys are stored within RAM so that they're quickly accessible, but only the values which are frequently accessed stay in RAM. All of the other values go into what's considered warm storage in SSD. Again, you take a slight performance hit with that. There's a little bit more latency, but you do have a great cost benefit trade-off between that performance for those really, really large caches. Now, active geo-replication is something that a lot of customers are very excited about. We do simultaneous read and write operations across clusters in an eventually consistent mode where the last write always wins. We can achieve worldwide scale using local latency. So this is a great thing for end users. Latency within region is local. However, if they were to travel outside of a region or if there had to be regional failover, all of their data is still available to them within the Redis clusters. So on that topic, I'd like to just take a moment to go over and jump out to our Azure portal and let's see what it looks like to stand up a Redis Enterprise cluster that has active. So we go to our portal, we navigate to Azure Cache for Redis. We click on Create, select a resource group. I have one already set up. You can always create a new one. And this one, I'm just going to call it AA3. It is available. We're going to go ahead and stand it up in East US. And our cache type, we're going to pick the smallest cache for enterprise, which is E10, and select our terms. Next, we have networking options. You can do a public endpoint or private endpoint. Since this is a demo, I'm just going with the public endpoint. Then on the advanced features, the first thing we do is select some modules. Let's go ahead and select JSON and search. Now we note that there's an error here. OSS cluster policy doesn't support Redis Search. Good to know. So we will select enterprise. Right now, we're not going to select zone redundancy, but I'll get to what that means here in just a moment. I'll select non-TLS because I am, again, in demo mode. And then I go down here to this second group and go into active georeplication, where, as you can see, I have a flush group that already exists, or a georeplication group already exists called SGN flush group. And then I can create a new group, or I can assign it to this one. All you have to do is select the checkbox and then configure. And you can see that if I was to do the review and create, I would actually go in here and I would join this group that I already have configured. So I'm going to exit out of here rather than create this. And I want to run a real quick command here because I'm going to send some commands out to our caches. Because again, as I pointed out, I already have a georeplication group and I want to show off one of the new features that we have available. So as you can see, I'm looking here at SGN Flush AA1. And what I want to show you is the flushing. So right here, we have preview for flush caches. I also have an instance up here of my Redis Insight where I can go and see. Now you saw that I added those keys just a moment ago. They're already here. Now note that I was pushing those keys into SGN Flush AA1 and they're already here in SGN Flush AA2. So one of those is in East US, one of them is in West US, and they've already synced with all of the keys that I've put in here. You can see these are small JSON documents, no real big deal, because that's not really what we're showing here. What I wanted to show was this preview of flushing the cache. So this will allow you to flush the entire cache across all the Redis clusters connected to the group. This is going to give me a warning here, which is a good deal. I'll hit OK and say, OK, cool. Go ahead and do that. Again, I did this process against not the cache we're looking at, but another cache that it's connected to. And here I can click refresh, and now you can see I have flushed my cache. There are no keys. And I can go back here. If I want, I can rerun this, and I will automatically just start picking up these keys very rapidly. So that is one of our new features available. So flush cache for georeplication. Start this slideshow again and continue. So the impact on HA and SLA is something that is very important with Redis Enterprise. So just by default, when you just configure a single cluster, like I was standing up there, if I wasn't going to join it to a group, my default would be 3 nines. Because I didn't choose zone redundancy, which is multi-AZ, by selecting that zone redundancy, you are placing the primary and secondary nodes in different availability zones within the region. So in the event that there's a partial outage of a data center, you won't have an impact upon your cluster. Any secondary nodes that are still available without a primary node will become promoted automatically to primary and will give you that 4 nines AZ. Now, as we just saw with active georeplication, you can get up to 5 nines as long as you use that multi-zone configuration alongside active georeplication, because you're getting those multi-primary writes across all regions. So now let's get into the Redis extended data structures, or modules as they're called within the Azure portal. There are 4 of them. We have Redis time series, Redis Bloom, Redis Json, and Redis Search. And without any further ado, let's just go into Redis time series and kind of see what that looks like. So in Redis time series, each key is a time series. So any key can have a bunch of labels, any number of labels set to it, and it can have multiple downsampling and aggregation rules. And that's really what's special about using Redis time series. So when we create a time series, what we do is we effectively are just going to create, just like we would, a Redis index or something, but we're going to give it a key, and we're going to say we want to retain it for this. We give it a label, sensor ID, and then we're going to, give it a tag. And so we're also going to create a second key, which we're going to store our aggregation in. So all you have to do to add into this first key is just add, just like you would using a normal Redis command. It begins with TS for time series. But we can create aggregations against it. In this case, we're saying we want to aggregate the values in TS:2 into TS2 average hourly, and we're going to average over 3.6 3,600,000 milliseconds, which is 1 hour. So now what this does is it's going to take any new data that comes into TS2, and it's going to put that data and append it into the average hourly. And so this aggregation allows you to aggregate on the fly new data that comes into the other key. And anybody who's ever had to write batch processes that are constantly checking for lagging data and then rerunning aggregations and doing downsampling for clients would understand that this is a boon in terms of reducing the amount of work necessary for both developers and the amount of work necessary for the clients that are connected to the system. So you can also do aggregation. You can do different kinds of querying using these commands, and it's very straightforward, much like the rest of Redis. And it all kind of comes together in this. This is a very human example where if you've ever had a lot of data and you've tried to visualize it in a graph, you can see it just comes out a mess. So you have to write that downsampling code, and then you can downsample it and view it in a human readable or human analyzable way to detect trends and whatnot. Again, Redis is doing this automatically for you. When you have lagging data, it automatically recalculates the aggregate and will continue doing this. So your developers and your client applications will thank you for the reduced work. So the next module that we have available is Redis Bloom. Now, Redis Bloom consists of 4 different probabilistic modules. And probabilistic means that they aren't 100% accurate, but they trade off accuracy for speed. So top K gives you the top amount of something, think leaderboard. Count min sketch is just going to do counts for you against keys that you have in the database. And Bloom filters and cuckoo filters are really the interesting ones that kind of give you the fastest existence checks of keys in your system. And they're excellent for things like fraud detection and deduplication. So you can tell the cuckoo that you have these hashes, and then you can say, hey, does that exist in this hash? And it'll either say probably yes or definitely no. So the next extended data module that we have is Redis Json. Redis Json was launched in August of last year and has become very popular with new developers. But really, first we have to kind of start with the question of why Redis Json. Well, the reason, a lot of developers and a lot of companies that have been using Redis for a long time have been storing their JSON data in Redis as strings. And that's fine, but every time you need to do an operation or a query against that JSON object, you have to serialize and deserialize the entire string up and down the wire every time. You can't do those granular operations, which you might need to, like appending to an array, without replacing the entire string. Now, you can get around this by modeling your JSON object into a hash. But since hashes can't contain other hashes, you end up with this complexity of trying to figure out how to make your hashes relate to each other in a way that you can reproduce your JSON objects. That becomes very complex and difficult. So the beauty of using Redis Json is that we can do nested elements and use JSON exactly like we would normally, exactly like probably our the data coming into our system could be, or the data coming from our clients might be. And you can store these complex objects under one key, and you can store them with a single command. You use a JSON path-like syntax to query these, and you can do in-place updates. So in this example, you can see that we're going to increment a number by 95. So user one's score goes from 5 to 100. We're doing that in place. It's a single command. We didn't have to pull that document down and push it back up. So the reads also operate this way. They're very granular. You can get the entire object. You can get one individual part of that object. Or like in this case, you can see that what we're looking at is we're looking at user one, profile.achievement, the first element in the array, and we want the ID for it. So you can get very granular in even your read operations. So we do offer very high speed ingestion for JSON documents. It's again native to Redis with Redis speed. And you can do things like getting multiple keys and only get the subtree of that key that you want. Like in this case, we're looking at user one has two tweets, tweet one and tweet two, and we want the likes. And so it's going to return for us an array of the values that it's retrieved. In that case, 105, tweet one had 105 and tweet two had 10 likes. So, this is a great example on how we can use that granular ability to get data out of Redis JSON. So now moving into Redis Search, which is by far our most popular extended data module. We think of Redis Search as the world's fastest search engine, and it's ideal for secondary indexing, catalog searching, and text and geo searching. But we support multiple language, document and field weights, exact phrase search, stemming, auto suggest, filtering, incremental indexing, and aggregations. And it's really, really quick. Throughput's very high, and latency is extremely low for Redis Search. And when we're using Redis Search, the first thing we have to do is identify what hashes we want and then specify a prefix to match against. Then we identify the key value pairs within the hash that matter to us and define exactly how they're going to be searched. We have to state what type they are, and we also have to say how we want the value to be treated. In the case of numbers, you might want it to be sortable, or you might want something like a fuzzy search on text. In this case, you can see there's an example for defining a schema where we're going to do a phonetic search against the favorite, and the votes are going to be numeric and sortable. In case you're kind of testing this out, you can drop indexes. Once you create an index, you can drop it and then experiment and kind of redefine the way in which you want to index that different text. So once you have that defined, you just set the data just like you would ordinarily in Redis. It's just the same Redis commands. We've already just identified that those hashes that start with RPS : are going to be indexed. In this case, we're going to do a fuzzy search, and we're doing with the percentages, I believe we're doing a Levenshtein distance against this index, and we're saying, hey, we want these two that match this within a certain distance from Levenshtein. And then we can also negate unwanted results. So in the last one, we had she as a name. In this case, we say we don't want she, we just want the other one, and it only returns the other one or anything that doesn't match that. So we can also search using this phonetic matching. So you can see this horrible misspelling of scissors without she still returns scissors spelled correctly as the data. Tags are another element of Redis Search. They only support exact matching. So I would think of that as like something that you would use for like an enumerated type or something that's a constant of some kind, because of that only exact matching. But using tags, you get super efficient search times. So if you have the ability to do that, and you could constrain your searches using that tag value, it's a really great way of optimizing your search. We can also do aggregations, group bys. In this case, we're saying we're going to group the votes, and then we want where votes are greater than 0. And we're also going to aggregate it into a total and then give us the total number of votes available. So the next section of this I kind of wanted to tackle has been very popular lately with the rise of ChatGPT and OpenAI and all the other AI ML engines out there. Redis Vector Similarity Search is part of the native search available from within Redis Search. So we provide that low latency, scalable in-memory vector storage and retrieval by distance. We use a couple of different indexing methods, HNSW or HSNW, flat, and then distance metrics, which are the way that we're calculating the distance between the vectors. So we also offer support for hybrid queries. So you can do a vector distance search against vectors in the database, and then you can filter that outcome by text in the same way that we just filtered the other data. And this is available in Redis Search 2.4, which is currently the version that is in Azure Cache for Redis Enterprise. So it's currently available to you now from within Azure. So here I just wanted to kind of touch upon this just in case there are questions. What is a vector? A vector is just basically a number. There can be several different numbers that represent a single piece of data, and those are called dimensions. And those dimensions are different types of those floating numbers that are used to calculate it using basic trigonomic functions. So the vector similarity searches also start with the schema, again, because this is Redis Search. You can see I have the syntax up here. We're basically saying that you want to create it. You have to give it an index name. You say that this is a schema. You define your vector field. Then you pass in the different types of algorithms you want and the different type of calculation you want, and effectively create your schema within Redis Search here, which you can then query against. So how does this look like overall, like in terms of an architecture? Really, basically, you have audio files, text files, video files, image files, and then you pass them into some kind of AI model, an audio model, a text model, a video model. And then the output of that becomes these vector embeddings, which you store in your vector database. In this case, we're talking about Redis, because Redis gives you that sub-millisecond latency, very highly efficient queries, and even when you're doing filtering and searching across the text, you get really high performance. So the use cases for this are things like, semantic search, semantic text search, deduplication, recommendation engines, data labeling, question answering, a lot of the things that we've been seeing that have been in the news lately. So now let's talk about the new features in Azure Cache for Redis Enterprise. We have several new features that are currently in preview and are soon to be GA. Connection audit logging is something I'll show here in a minute. We just looked at that flush command. Scaling up and out for Enterprise and Enterprise on Flash, as well as customer managed keys for Enterprise persistence. So let's go back out to our Azure portal and have a look and see what that looks like. So we'll go back here again, back into Azure Cache for Redis. Go to create, select my resource group, give it a name. East US is fine. Again, we're going to pick that E10, select our terms, networking, still public. We're going to give this a couple of modules. Enable TLS. Something I didn't mention when we were talking about active georeplication was this data persistence. This is fairly straightforward. We do have data persistence. We can take RDB snapshots or do AOF files. RDB are, as I said, snapshots. They can be taken at a frequency of 60 minutes, 6 hours, or 12 hours. And AOF is an append-only file, which you can always write to with every write into the database, or you can write every second. So there's a little bit of buffering there. Now, RDB files are more efficient and more quick when you're restoring a database, and AOF files are more accurate depending on the time window for those RDB files. So you just kind of have to balance between those things. Now, here at the bottom, we have the customer managed key encryption at rest, which is a very new feature. There's a couple of things you have to have already pre-configured to use this. So in this case, what we need is a user assigned managed identity, which I already have here. And I select it and add it. And then that'll fill up some of these. So now I can use my management pool. I have a key vault already in this region. It's a persistence vault. And I've already created a key within that key vault, which I've called persistence key. And that persistence key has one single version right now, which I will select. So now if I was to review and create this, any data at rest would be encrypted via the key, which I have stored in my persistence vault. So I'm not going to deploy that. Instead, I'm going to go ahead and go to one that I've already configured just the same way that I just did this last one, because there are a few other things I'd like to show off here. One of these is scale. Now, it's kind of interesting because on the enterprise tier, it's usually best practice to scale up before scaling out. It says right here at the top. Now, what does that mean? So when you're looking at your Redis Enterprise tier, you might see a number of things. Maybe you feel like the CPU is very high. Maybe you're having connection timeouts, or maybe you're seeing that you're using the using almost all of your storage. So you're topping out your storage with the enterprise cluster. So what we do and what we think about is if you're having CPU issues, if you're having connection issues, scaling up makes a lot of sense because you're going to get on a higher class of VM. You're going to have more cores available to you. So you're going to have better CPU and you'll have better connection. Now, with the capacity itself, if you are on a 12 gigabyte cache and you're at 12 gigabytes and you're noticing a slowdown, it's probably because of key evacuation, in which case you could scale out into more nodes. That isn't going to necessarily give you better CPU performance. It's not going to give you better connections, but it will give you more nodes and give you more capacity. So you have to kind of think about that. And there is an article about scaling best practices, which covers these things. So I suggest you look into that and think about it. But what we can do is scale this up in capacity. In this case, I just clicked save. My capacity is going to go from 2 to 4. I'm increasing my total size of my enterprise E20 to 50. Then the last thing I wanted to show here is the diagnostic settings. Now, we mentioned that we're doing audit connection or connection auditing. In this case, we have just this one category, audits, and that's connection events. I'm sure there will be more categories available soon, but this is the one that's available now. There are several different types of destinations for which you can send these connection events. You could send this into a log analytics workspace. You could archive it to a storage account. You could stream it to an event hub for on-the-fly analysis, or you can send to a partner solution. And again, there's a good article link here. You can go and learn about the different partner integrations that are available to you. You would just select the destination. Obviously, you'd have to have that pre-deployed into your subscription. So worthy of note is that there is more than one option available to you within these. So you could stream for on-the-fly analysis while archiving into your storage. Okay, back to our deck. And thank you. I want to sincerely thank you for taking the time. Continue learning about Azure Cache for Redis Enterprise. You can always reach out to your team at Azure, or you can reach out to the folks at Redis to give you guidance or any kind of help or assistance you might need. Please just let us know and stay in touch. Thank you again. Take care.